Hi everybody, my name is Setender from Patender Academy. My question is transformation a problem to you? Okay, if so, then enjoy learning it in the comfort of your home. If you like it, please do subscribe. Okay, so what is to transform? To transform is to change, changing the position, the size, or even appearance of any shape. That is to transform. Okay, so there are almost 6 ways of transforming a shape. That is translation, a reflection, a rotation. These first 3 do not change the size of the shape. The shapes will remain the same in terms of size. Okay, but these 3, enlargement, to enlarge, to stretch, to shear, they do affect the sizes of shapes. Okay, so I want to go through one by one from translation up to shear, but in this lesson it will be a lesson of translation. So what is translation? To recognize translation, the object and the image will be exactly the same in terms of size and appearance. That is translation. So how do we tackle questions concerning translation? For example, this question, it's saying translate triangle A onto triangle B with the translation vector 6, 6. That vector 6, 6, like column number, that is added, is a column number that is added to the coordinates, to the vertices of the object. So to translate, you just add the translation vector to the coordinates of the shape. Okay, so here's our triangle A. Right. We want to translate this triangle with the vector 6, 6. So my coordinates of triangle A, 2, 0, plus 6, 6, 2 minus 4, plus 6, 6, then 4 minus 4, plus 6, 6. Okay? So it's 10, 2, 8, 2, 8, 6. Okay? So let us draw a triangle B. So it's 82, 10, 2, then it's 8, 6. Let us draw. Here's our triangle B. Okay. Okay, let me erase this. Right. This is the triangle B. As you can see, triangle A and triangle B are exactly the same. That is translation. Translation does not change the size of the shape. Okay. So, okay. Another different question now. Describe completely what maps triangle A onto triangle B. Now, triangle A is there, triangle B is there. How do you prove this is translation? We have to join corresponding points. Joining corresponding points of A and B. Okay? Okay, let's go again. Okay, the last point. Right. You see, there is the formation of these parallel lines. So, formation of the parallel lines, it proves that it will be translation. Okay? So, what next from there? We have to describe it completely now.
So let us subtract the image subtracting the object. So this is the image, this is the object. Even this point corresponds with this point. So trying this one, it's minus 2, subtracting 8, 4. It's minus 10, then it's minus 6. So describing completely is asked by the question. This is translation with vector minus 10, minus 6. So this is how to describe completely a translation. You have to state the translation vector and also to state that this is translation. Another way of finding the translation vector, let's say this point corresponds with this point. So let us join this point. Joining this way, going the, okay, then unto the formation of a right angle here. Okay, so our scale was saying 2 centimeters to represent 2 units. So each and every full box represents 2. So this is 2, this is 4, 6, 8, 10. Okay. Then for y, this is 2, this is 4, this is 6. Okay. Right. But now we have moved going the negative side of x, so it's a negative movement. Then we have moved also going the negative side of y. This is the negative movement of y. So the translation vector is minus 10, minus 6, starting the x coordinate. So it's minus 10, it's minus 6. So you're saying this is translation with the vector minus 10, minus 6. This is also another way of finding the translation vector. It's true for every point. I only choose this one and this one. It's true for whatever point you may like. So this is the other way of finding the translation vector. Or you can choose the first one, the first example, where you can subtract the coordinates of the object from the coordinates of the image. Remember, it's image minus object.